Hi class, and welcome to our video lesson on Parallelograms, Chapter 8, Lesson 2. So we'll define a parallelogram. A parallelogram is a quadrilateral with two pairs of parallel sides. So this side and this side are parallel. They will never ever touch each other. They have the same slope. And this line and this line are parallel. They have the same slope. So a parallelogram is a four-sided figure, a quadrilateral, with two pairs of parallel sides. There are 6 properties of parallelograms that I want you to know. Okay? A couple of these you've maybe heard before, a couple of them you haven't. In a parallelogram, the opposite sides are congruent. So if this is 7 feet, this one is 7 feet. If this one is 3x minus 4, and this one is 12x plus 17, whatever the case might be, you would set them equal to each other because the opposite sides are congruent. Opposite angles are also congruent in a parallelogram. The opposite angles are congruent. So if this one is 120 degrees, this angle is opposite. It's also 120 degrees. So opposite angles are congruent. The consecutive angles are supplementary. They add up to equal 180 degrees. If this one is 50 degrees, this one has to be 130 degrees. And then again, because opposite angles are congruent, then this one has to be 50, but these two are also supplementary because they're consecutive. These two angles right here are consecutive, so they're going to be supplementary, and obviously opposite angles are congruent. So these two properties really work together. Another property, if one angle is a right angle, then all the angles are right angles. So if this angle is 90, well, opposite angles are congruent, so then this angle has to be 90. And if consecutive angles are supplementary, 90 plus what equals 180? Well, 90 plus 90 is 180, so that means this one has to be 90. And then opposite angles are congruent, so this one has to be 90. So bottom line, in a parallelogram, if one angle is 90 degrees, then they're all 90 degrees. And then this is an even more specific type of parallelogram. It's called a rectangle. We'll get to that in a few days. DB means that the diagonals bisect each other. So if this diagonal right here is 20 feet long, the diagonals cut it in half, so then each, whatever I said, I don't know if I said 20 feet, then this would be 10 feet and this would be 10 feet. If this right here is 30 feet long, then each piece, each segment would be 15. And then the last property is that a diagonal makes two congruent triangles. One diagonal makes two congruent triangles. And the reason for that is if this side is parallel to this one, we would call this line a transversal. And so a transversal makes alternate interior angles congruent. So this angle is congruent to the alternate interior one, and this angle is congruent to its alternate interior. And then by the reflexive property, they both share this red side. And so by angle, side, angle, angle, side, angle, they are congruent triangles. So one diagonal of a parallelogram creates two congruent triangles. So those 6 properties I want you to know that are true of all parallelograms. Okay, so now let's answer some questions. Wxyz, let's find the measure of that. So what is the measure of angle xwz? Xwz is this angle right there. Well, let's go back to some of our properties. One of the properties of parallelograms is that opposite angles are congruent. So class, do we know the measure of this angle? Sure we do, right? It's 50 plus 70. So the measure of xwz is equal to its opposite angle, which is xyz, and xyz is 120. So that means xwz also has to be 120 degrees. It also says find the measure of xwy. So angle xwy equals, let's see where xwy is. Xwy is this angle right there. I'll erase the red arcs here so you don't get confused. So xwy. All right. Well, a diagonal such as this one creates two congruent triangles. So this triangle in green is congruent to this triangle in blue. And then this red transversal makes alternate interior angles. So this 50 degrees is congruent to this angle right here. So our answer then is 50 degrees because of alternate interior angles. That means this angle right here is 70 degrees. So then if we wanted to, we could find the measure of this angle because in a triangle there's 180 degrees. Same thing as this one. Okay, let's try the next one. Find the value of the letter A in parallelogram Wxyz. So it tells us that it's a parallelogram. So whenever you read that word, it's really telling you 6 properties. Opposite sides congruent, opposite angles congruent, one right angle, they're all right angle, consecutive angle supplementary. All those 6 properties that we talked about a few minutes ago. So if I want to find the value of A, right now there's 2A for Wx, and this one right here is 30. What can you say about Wx and Zy? Well, opposite sides are congruent. So in algebra, we would say that they are equal. So 2A, that side length, is the exact same length as Zy, which is 30. So 2A equals 30. Clearly divide both sides by 2, so A equals 15. And there we have that one. The last one for the day. We see a parallelogram like this. Find the value of x, y, and z. I guess the instructions don't tell us that this is a parallelogram, but if you look at the picture, this arrow and this arrow are parallel. So this side with the double arrows and this side with the double arrows are parallel. Opposite sides are parallel. That makes it a parallelogram. So let's just go in alphabetical order. We'll find x first. So here's x. Well, GE would be a diagonal, and DF would be a diagonal. And one of the properties of parallelograms is that the diagonals bisect each other. So x equals 15. The diagonals bisect each other. So if GH is 15, H would be the midpoint of GE, so HE is also 15. Let's go onward. We want to find y now, and y is right here. This is very similar to the last slide that we just got done doing. A diagonal creates 2 congruent triangles, so alternate interior angles are congruent. If this angle is 48, its alternate interior angle is also 48. So y is 48 degrees. Our last one, again very similar to the last slide, to find letter z in this case. We know that 5z minus 10 and 3z plus 15, those are opposite sides. In a parallelogram, the opposite sides are congruent. So 3z plus 15 equals 5z minus 10. Let's solve for z. Subtract 3z over to the right side, add 10 over to the left side, and we get 25 equals 2z. Divide both sides by 2, and we get 25 halves, or 12 and a half, or 12.5. Any of those would work. There's x, y, and z. Those 6 properties are very, very important. We're going to be talking about those in the next few days because we'll be talking about more specific shapes that are parallelograms, and in each parallelogram, all 6 of those properties remain true. So make sure you have those, a good knowledge of those as we move forward.